Hello there, I'm Thomas Hatsios, the British American pilot of the United States Air Force, flying the Boeing 777-300ER airliner aircraft in tonight's flight from Zurich International Airport. We're going to be flying Zurich, Switzerland, Germany, and then coming back to the Zurich International Airport runway 14 for now, localizer landing. So now I'm in the cockpit for the pre-takeoff preparation of the Boeing 777-300ER XOTP simulation, Microsoft Flight Simulator. So I'm going to start showing you the cockpit instruments and the displays of the Boeing 777-300ER airplane. I'm gonna start with the primary flight display. I will show you the airspeed indicated tape with the airspeed selected and the ground speed displayed. We have also the radio altitude. We have the barometric altitude above the sea level setting with the target altitude selected from the autopilot and flight director system panel, the barometric altitude of the outside atmosphere pressure setting, also the magnetic heading and track, the magnetic north pole and the true north pole, and the magnetic variation depending on where we are in the world. We have also the flight director and the angle of attack of the aircraft as it flies in the air. We have the flight director, we have the altitude indicator with the flight director crossbars, the ILS crossbars for manual guidance, and also the autopilot crossbars for automatic guidance of the aircraft. So we have also the pitch ladder in decrease and the bank angle in decrease. We have the flight mode annunciator with the autopilot and the auto throttle lateral and vertical navigation modes, and the rate of climb descent of the aircraft in tens, hundreds and thousands of feet per minute. Rotary tonometric angle in decrease. So this is the information displayed using the ADIRU, the Air Data Inertia Reference Unit system in the overhead panel that controls the air data computers like the pitot static and pitot anemometric, the pitot dynamic for the airspeed, and the pitot static for the barometric altitude, and also for the rate of climb descent, the magnetic profiles, and the GPS receivers for the navigation display and the radio altitude. So this is some of the information. Also we have the laser gyroscopes that regulate the attitude of the aircraft, the rate of turn of the gyroscopic turn pulsation and deceleration, acceleration and deceleration rates using the laser gyroscopes, which are also controlled using the data inertia reference unit, the ADIRU in the overhead panel I'm going to show you later. So after that I'm going to show you the navigation display, that displays the aircraft position, the GPS, the inertial reference position of the aircraft. We have the airport's waypoints, the nav aids displayed in the navigation display. We have other aircraft flying around us using the TICA system, the traffic collision alert system, that uses the transponders ADS-B and ADS-C. We have the terrain level displayed using the weather radar with red, green and yellow. You can see the elevation of the terrain in front of you and in an angle of like 90 degrees. So we have the GPS and terrain map. We have also the rates of all this information, and we have the magnetic heading again and track. We have the wind direction and speed, and also we have the next waypoint we have to be overflying, and the RMP and the AMP, the required navigation performance and the acquired navigation performance of the aircraft. So we have about an hour 10 minutes left for this flight video. So after that I'm going to show you the autopilot and flight director system panel, the autopilot and flight director system panel that contains the autopilot engage and disengage switches, the auto throttle left and auto right engage and disengage switch, the flight director engage and disengage switch. We have also the airspeed select knob. We can select the airspeed in nautical miles per hour, knots, or Mach speed, and we can select the modes for the thrust produced by the engine. We have I will explain you later, General Electric 90 turbofan turbojet engines installed in our aircraft, one in the left wing and one in the right wing. So it's it's a dual engine aircraft. So you can see here we have the autopilot. So we have the airspeed select knob. We have the modes we can select, like the auto throttle, the auto throttle hold switch with the speed, and the climb continues and the flight level change. So we can select fixed thrust from the engines when we climb, like maximum continuous thrust, or when we descend, like idle thrust, and variable thrust modes when we cruise level or when we are approaching for landing. We have the variable thrust modes of the engines. Using the FATEX are the full authorities electronic control computers installed in the engines. I will explain you later. So we have also the LNAV and the VNAV, the lateral navigation and the vertical navigation modes. We have the bank angle limit for the autopilot when we fly. We have it in the auto right now. We have also the heading letting up and the heading hold switch, the rate of climb and descent of the aircraft, how fast it climbs or descends, intense 100,000 feet per minute, or a trigonometric angle in decrease, and also the bank angle limit and the altitude select knob and the altitude hold switch, and we have the VOR localizer for the Lszh localizer, and also the approach for the auto land function of the Boeing 777-300ER airplane autopilot function. So you can see here some of the instruments inside the cockpit. So after that, I will talk to you about you can see here we have the primary flight display, the navigation display. Here's the autopilot and flight director system panel, the upper and the lower ACAS and the indication controller system display, the thrust levers, the flight management computer. Here's the yoke, the control column, the control wheel of the Boeing 777. So I'll show you all these instruments, what they're doing, also the overhead panel. After that, I will talk to you about the engines, the thrust levers and the engines, the FATEX. I will show you how to use them to activate the thrust produced from the turbofan to the engines. Then I will talk to you about the flight theory of the aircraft. I will explain you how fast we have to be accelerating the runway for takeoff, and how many flaps, degrees of flaps we use, and how much of horizontal trim stabilizer or the horizontal tail stabilizer. We're gonna use the flight management computer to make all these calculations. Then I'm gonna explain you about the flight controls of the Boeing 777-300ER airplane. Then I'm gonna show you the overhead panel and things like the electrical system of the aircraft, the IDGs, the degrade drive generators, which are installed in the left and the right engine gearbox, which produce alternate current part for the aircraft. Also the batteries and the APU, the auxiliary power unit, we're going to be using for starting the engines. I'm going to shut down the engines after all this, and show you how to make a restart using the auto start system. Also I'm going to show you the hydraulic pumps, the left and the right engine, and the electrical backup. Other systems like the ADIRU, the flight control computers, the EC, the electronic engine controls for the engines with the auto start. The wing and the center fuselage tanks, the fuel tanks of the aircraft, and the forward and the aft pumps, the closed valves, the fuel feed valves like fuel cutoff valve switches for the low and the high pressure fuel valves. Also I'm gonna show you the wing and engine LDS, the cabin pressurization system, and the bleed air from the left and the right engine. We use for cabin pressurization, wing and engine RDIs for air conditioning and ventilation, and also for the hydraulic fluid tanks pressurization of the C1 and C2 system. The electrically compressed hydraulic fluid, not the engine driving. So I'm gonna so thank you very much one more time. I'm Thomas Hatsios, the British American pilot flying the Boeing 777 of the United States Air Force, flying the Boeing 777-300ER in tonight's flight. So I'm gonna start now. We have like the 8. So actually we have like 1 hour 7 more minutes. So I have to be very, very fast. You can see the outside view of the Boeing 777, the aircraft, and where we are located. So you can see here we have the primary flight display. That displays the airspeed indicated. The minimum airspeed indicated is 30 knots, the ground speed is 0. The airspeed selected from the autopilot flight director system panel with Matzeda. The altitude selected from the target altitude selected from the autopilot flight director system panel. Also, here is the elevation of the aircraft above the sea level, 1,430 feet. The barometric altitude setting of the outside atmosphere, magnetic heading and track, and also this is the altitude indicator, the laser gyroscopes calculate this, the rate of turn of the aircraft in the positioning. So we have this, the pitch ladder indicates the bank angle limit, and also you see this purple crossbar is the flight director. We can turn into autopilot function. This is the rate how fast the aircraft climbs or descends if the needle goes up or below. This middle line here, the positive 1000, 2000, 6000, minus 1000 or 500 for instance. So we can set also meters to display here, meters and hectopascals instead of inches of mercury, so you have hectopascals now. I can set also this is the flight level change. We will set higher airspeed for takeoff and for flying. You will see we can set indicated airspeed or Mach. We have the auto throttle left and auto throttle right. We will see the auto throttle left as a message here is off as a warning. Auto throttle L. For the other side you have the auto throttle right here. So you can pay attention to that. You can turn off both. Flight director on and off again. We will cancel the airspeed. So I will set this like that. You have the LNAV, the VNAV, also the bank angle of the aircraft, auto, or select a value. We can cancel this and select I will select the heading of the runway for takeoff and the hold, also the altitude here. We're gonna be flying. We select make. We can select either one. So we have 35,300, the target airspeed, 35,300 feet for climb, 7,710 meters, flight level change speed, 1,013 hectopascals, back to the inches of mercury. You can set 39.80. 0.90. We'll set this back to the 92, 91, 92. So we have the 92 here, 39.92 standard. The barometric altitude setting, heading or track. We can select the autopilot here on. You can turn off like this if you pull out this switch here. You will see the warning back on. So you have the warning here and here. The autopilot has been disconnected like this. So you reconnect again and press the green light is on. So we set the altitude, the target altitude here, 35,300 feet, 7,910 meters. 432, 7. So you can see the navigation display, the airports. So we have here's the Switzerland, here's France, here's Germany. You can see the terrain level 6,100 feet maximum, 0 feet minimum. Heading track, magnetic. So we have the nav of the winner. So we can set here the rate of climb and descent, like minus 3.5. You will see negative. I will set the plus for climb. So you will see the degrees here with the autopilot connected, 3.5 degrees display. And we have also tens, hundreds and thousands of feet per minute, like minus 3,200 or plus. You will see the slider here, plus 3,500, and you have the indication here in the rate of climb descent, the tape here. It will display 3,500. This much data. Here this sign. So after that we have a couple more things to do. So we have less than 1 hour now left. So I will continue. I will show you again how this disengages the autopilot. I have to show you this. Press this switch in the handle of this control wheel. You will see the indication again. This is the autopilot disconnected, and the flight director here is on the green light also. So you cancel one more time, you press, and it's cancelling the confirms the autopilot disconnect. So this is all you know. You can leave the flight level change on maybe how to use for the cockpit. So I'll show you a couple more things inside of the cockpit, like the control wheel and the control column. We'll show you the thrust levers. You can see the speed brakes are retracted when we push the thrust levers forward automatically. Also, when we move the thrust reverse, they expand automatically also. So you will see the reverse thrust now. The indication. The reverse thrust. The blocker doors are open. So we cancel the thrust reverse. And we extend the reverse again. The blocker doors are open. So we cancel the thrust reverse. So I'll talk to you about the thrust levers and the flight theory of the aircraft. I will show you also a couple more things inside the cockpit. So you can see here we have a few instruments. I will explain you later. Alongside with that, also the flaps here, you can see. We pull the flaps up, you will see the indication changes there. Pull up or pull down the flaps like this. So it will display here like flap 30. You can see also the total fuel inside the aircraft. Fuel tanks is balanced. So I We'll talk to you about the thrust levers now. We use the thrust levers to accelerate the thrust of the aircraft produced by the engines. As I told you, we have the General Electric Z90 turbofan turbojet engines, one installed in the left and one in the right wing for symmetrical thrust and redundancy. Also, we have the FADECs. The FADECs are the full authority electronic control computers, one installed per engine. Gearbox is self-contained electric power, one installed per engine. Dual channel redundancy, one channel fails, the other takes over. Controls and monitors all the data and indications using the upper and lower engine indication controller system display. For the engine management, like the N1, which is the low speed shaft, the low pressure compressor and turbine of the turbofan turbojet engine. General Electric 90, also the exhaust gas temperature per engine. The N2, which is the high speed shaft, rotor shaft, also it's the high pressure compressor and turbine. And the turbofan turbojet engine, the fuel flow per engine per hour, the oil temperature, oil quantity, oil pressure, and the vibration of the N2 stage of the engine in inches. Horizontal vertical inches, so you can see the vibration of the engine also. So this information is useful. Also controls and monitors the engine start, the engine shutdown. It optimizes the fuel efficiency of the aircraft, the safety. So it also regulates the outflow valve from the 5th and 9th stage of the aircraft turbofan turbojet engines. If we have an overpressure inside the engine stage, it opens the outflow valves into a higher stage to relieve the higher pressure. Also, when we have an under pressure, it closes it. It closes them to increase the pressure inside the engine. This is also useful when we climb into higher or lower altitudes. We have different air pressure ratio and oxygen levels. Also, the aircraft flies faster, so we have a higher intake of air mass from the front fan stage of the engine that is being compressed and burned, ignited with fuel into the burner stage. So it also optimizes this the fuel efficiency and the fuel air mixer, so we don't have to regulate the fuel air mixer using the switch like in the general aviation aircraft like Cessna Skyhawk. So it's all done automatically, so it's a good thing to have the FADECs, the full authority electronic control computers. Also receive the signals from the autopilot and flight director system panel, the auto thrust system, the flight management computer inputs. I'm gonna show you later. So you can also disconnect the auto thrust from using the auto thrust disconnect switches in the thrust levers. So when you move the thrust levers into a position, you command a thrust lever at TLA angle, thrust lever angle, equivalent proportional to the angle the level of thrust produced. From idle all the way up to the maximum continuous or takeoff ground path limits that I'm going to show you in the upper and lower engine indication controller system display. So you can see here, as I told you, have the upper and the lower engine indication controller system display. You can see the N1, which is the low speed shaft, the low pressure compressor and turbine, and the exhaust gas temperature of the turbofan turbojet engine of the General Electric 90. You can see limit 104.6% for takeoff, maximum takeoff and continuous thrust. Maybe we have the yellow and the red, and never exceed some other limits. The duct pressure, the cabin pressurization system, the total fuel, some other information related. The engine, the N2, which is a high speed shaft, rotor shaft, the high pressure compressor and turbine, the fuel flow per engine per hour, the oil pressure, oil temperature, oil quantity, and the vibration of the N2 stage of the engine. So when you move the thrust forward, you will see the engine produces 100 produce the equivalent proportional request from the thrust lever angle. As you can see, we will move them back. I will show you to the idle and then the thrust reverse. So we cancel the thrust reverse. Move it forward. So this is all in all most of the things we need to know. Also we have here, it's the auto throttle disconnect switch, the takeoff ground switch. Here is the fuel flow frenzy per hour. If we press the takeoff ground switch, we have to cancel this audio. So some other instruments around here, I told you the flaps, the speed brakes, you extend when you have the engines in idle. The flight controls, I will show you now. The horizontal tail trim, the stabilizer of the horizontal tail trim, and the cutout of the horizontal tail trim stabilizer auto trim functions. So I will show you also that. So I will explain now a little bit about the flight theory of the Boeing 777-300ER aircraft or any other aircraft. So right now with this aircraft, I'm going to talk to you about the Newton's physics per second, the law of kinematics of motion, also the aeronautical and aerospace engineering, some Bernoulli theory, so some physics and some mathematics. So I will show you with this aircraft right now we have 254,000 kilograms of takeoff weight, which is below the maximum takeoff weight. It's equal to 521,000 pounds approximately. So we have only 46,000 kilograms or 102,000 pounds of fuel on board. In our fuel tanks, it's only 30% of the total fuel we can take. In the fuel tanks, we have only 20,000 kilograms of passenger cargo, 46,000 pounds. So in total, we have 246,000 kilograms or 531,000 pounds. So with this weight for this runway, length and conditions like the weather conditions and the atmospheric pressure and temperature, we need to use full takeoff power. We're going to use also 15 degrees of flaps and 4 degrees of horizontal tail trim stabilizer, of positive horizontal tail trim stabilizer. So we need to overcome the stall speed. It's going to make the aircraft wings stall for a given angle of attack. It's going to make the airflow above the wings detach and turbulence. So it's going to make the aircraft fall back into the ground. If we are in the air, we have to apply the stall avoidance maneuvers. So I will show you also that we have done when we do the flight. So this is all in all. We need to reach the takeoff speed to have the effective lift component. The lift is the force that makes the aircraft fly into the air. It's produced by the wings and is must be equal or higher than the aircraft weight. The weight of the aircraft is equal to the mass times the is equal to the mass of the aircraft times the acceleration of the Earth's gravity. So we need to overcome this force. We're gonna use the lift force for the wings also to reach the takeoff speed and the flying speed limit. We're gonna be applying the thrust from the engines, the forward propulsion from the engines. So I'm gonna show you also that. I will show you a little bit the outside view of the aircraft, talk to you about the flight theory, and then show you the flight controls, how to use the flight controls of the aircraft. So you can see here we have the outside view of the airplane. So you can see here. So we have some time for this flight. You can see the wings of the airplane of the Boeing 777. You can see the surface area of the wings. I will talk to you now about the Newton's physics and Bernoulli theory and aerospace and aeronautical engineering physics and mathematics. So this is the surface area of the wings holds the total weight of the aircraft. Also we have the airflow as the aircraft accelerates. So you can see We have the mean aerodynamic chord position. Here is 25% of the wing chord, approximately from the forward leading edge. So it's the position where the maximum aerodynamic lift is being produced, and also the position where once the stall, the airflow begins to detach from the top of the wings and the stall begins. It's also the position where the center of gravity, the vectors, the horizontal, longitudinal, the lateral, wingtip to wingtip, and the vertical axis are being transversed to the center of gravity of the aircraft. You can shift the center of gravity of the aircraft forward or at this position by shifting fuel and passenger and cargo, make it less or more stable. So we have more vectors. You can see the left and the right wing to front two with the wing tap to propulse the aircraft forward. We can only propulse it, move it forward, and not make it climb. We need the lift from the wings. We have other forces also applied. We have the moment arm and the lever arm from the tail, from the horizontal tail and the vertical tail that make the aircraft climb up and climb down, descend, climb up and descend. Also bank roll left and bank roll right. So you can see here the wings, the bottom surface of the wings is more flat, while the top surface is a lot more curved, and we use also the flaps and the slats to increase the curvature. So the bottom surface of the wings, the airflow, the air mass of the aircraft moves forward, is moving slower below the wing. So the air has higher air pressure below the wing, which pressurizes the aircraft up into the air, which is positive air pressure. Above the wing, the airflow of the air mass is moving faster, so the air pressure above the wing is having lower air pressure. So it has negative pressure. So we have differential pressures. Positive pressure below the wing pressurizes the aircraft up into the air, and negative air pressure above the wing creates a suction, a gap of air above the wing. So it's some of the explanation. So I will show you now other forces like the deflection of the gases of the airflow using the ailerons and the spoilers that create the lever arm, the motor arm, and the wings that make the aircraft bango left and right. Also picks up using horizontal and vertical tail. So the moment arm or the lever arm is times the distance from the center of gravity all the way back to the horizontal or the vertical tail, or from the center of gravity to the left and the right ailerons and spoilers. So it's times the distance, times the surface area, times the airflow of the air mass per second. So you have to deflect the airflow of the air mass per second as you fly. And also it's times the acceleration of the Earth's gravity. So you make the aircraft pitch up and pitch down, and bank roll, turn to the left and turn to the right, so you have full directional control. So this is some of the forces. You can see the intake from the front, the engine, the exhaust from behind. So I will show you now the flight controls. I'll come to the other section of the flight now. The flight control sections. You didn't see the yoke here. We have the vertical the column, which controls the horizontal tail elevator, and also the control wheel which controls the left and the right, the ailerons and the spoilers. Also the rudder pedals control the yaw of the aircraft. So I'll show you now how we control the flight controls, how I control them here in the flight simulator using the side stick that creates a proportional deflection of my side stick to the control of the yoke of the flight controls of the Boeing 777 aircraft. So I'm gonna start right now to display that and make some explanations. So you can see I'm having this side stick here, the Lszh Extreme 3D. You can see I can pitch up and pitch down. You can see the control column. the yoke of the Boeing 777. And the control we can bang roll left and bang roll right. You have proportional side stick deflection and yoke deflection. So you can leave neutral, you can also pit stream. You can make small adjustments if you need. You don't have to move it too much. So also the rudder pedals left and right. Also the thrust levers here using this switch. You move forward enough. The speed brakes, the flap settings. So this is all in all how I use the side stick. I cancel this warning. So also now the outside view of doing the same thing of controlling the flight controls of the Boeing 777 using my side stick. So you can see, and we have like 20 minutes left for starting the flight, maybe faster. So you can see we have the flight controls again, pitch up and pitch down, climb and descent. You can see it takes some like a second for the full deflection to take place of the flight control. Maybe. Also the other ones, it takes like 1 second or 2 for the hydraulics maybe to move the control surface. So it's a little bit slower for the hydraulic fluid system to activate using the flight control computers, because it's a fly-by-wire aircraft. So this is all in all how we control the aircraft. We can use the horizontal tail, the elevator, climb, descend, the vertical tail stabilizer, the rudder, turn left and turn right, the yellow, and also the ailerons and the spoilers, bang roll left and bang roll right. So you can hold again neutral and use the horizontal tail trim, applying thrust from the throttle. So this is all the explanation. I'm gonna show you now inside the cockpit, a couple more instruments, and show you after that how to make the engine start demonstration after showing you the overhead panel. So, and also the multi-function display. So we come here. You can see we have the landing gear here, the up and down. This handle, you can see the display is down and lock. You can see the alternator, we have a failure of the normal. You can see the auto brake here with the takeoff for maximum, the flap limit, some indications, and the warnings here the terrain overrides some other functions. So I told you we have the horizontal tail trim here, and here is the control. This is the flight control wheel. You can trim up the ground. You can see the aileron trim position, but you have to set the aileron trims and the rudder trims here. You will see the rudder trim here. You can see the trim tabs we use also for pitching up and pitching down, the horizontal tail trim, and the position decrease here. Also, I'm gonna show you later, we have it in this display. So I told you we have the fuel flow to the engine, we have the fire extinguisher, and this is the horizontal tail trim, the speed brakes, and the horizontal tail trim stabilizer. We have a failure of the CMDR hydraulic fluid system. We can disconnect from the normal to the cutout the system, the CODR, the auto trim function from the horizontal tail trim stabilizer. So we'll have only the manual trim here, input here, and the alternate here. So the autopilot won't have, or the auto throttle system won't have the auto trim function, because this is controlled also from the flight control computers over here. I'm gonna show you later. Now we have also other systems, the radio communication panel, the transporter, a DSB and a DC, the TCAS system, the receives and transmits our position, other aircraft position, is a passive radar. Display, you'll see other aircraft and the warning here. In the display we have collision avoidance. The other aircraft, TCAS pass. We have the weather and terrain radar here. So this is a few of the systems we have. Also we have the tiller. Here is the nose wheel steering of the aircraft. So I will start now with the overhead panel. Maybe I will come here, I will show you this nicer display. So we have like 17 more minutes. I have to complete this section, so and make the engine start demonstration. So we have the overhead upper panel. You can see this controls is for disconnecting some hydraulic fluid, some I will show you first the cockpit inside this view. So we have this nicer view of the cockpit over here. So this is for disconnecting the hydraulic fluid. This is some resets, some circuit breakers, some systems if they have electric power fault. You can reset them in flight if they pop out, or you can replace some of them. So I will show you here. Again, we have the same system. You can see the cutout trim, the parking brakes, up and down. Again, the speed brakes. It's another nicer display. The fuel control to the engine, the cutout, and the fire extinguisher. So flaps up, 15 degrees, flaps up. You will see 15 degrees. We're gonna use this for takeoff. Also, you can see this nicer view here, this displays, and also the autopilot here. So we have a nicer view over here, more flat, more clear of what's going on. I will show you the overhead panel now. I will start first the APU. Need the APU power for starting the engine to be turned off. Here we have the flight control computers, primary, the thrust asymmetry compensator. So we have the left and the right engine. Driving IDGs, integrated drive generators that produce alternate current for this aircraft, 120 to 200 volts, 400 Hz frequency, constant frequency, 3-phase alternating current, 100,000 kilovolts left and right engine using the drive shaft from the rotor of the turbo handle engines in the gearbox, electromagnetic alternators, bipolar, north and south poles. We can turn this current, this alternate current directly using the transformer rectifier. We also have 38 volts, 48 hours using the batteries here and here. Also later we have the backup generators. We have the hydraulic fluid pumps, left and right engine driving, hydraulic here and here. Also the display and the backup which are pressurized from the engine system, the bleeder. So we need some systems for the flight control, some for starting the engine. Also you will see this is the ADIL, the air data and Lszh reference unit. I told you that displays all the air data, gyroscopic acceleration, deceleration, altitude, airspeed, radio altitude, magnetic heading or true heading, GPS receivers position. So all this information you need to use this system. So we have a few more minutes. For this flight we need to complete a little bit faster this time. So you have the hydraulic fluid here. I will turn off all the pumps and you will see what it happens in the displays. Hydraulic and the demand in the primary will be off, so you will see the fog coming up. You see, and here we have the display. It's popping up some messages because we're losing some systems. Also here the flaps are alternate and the stabilizer is lost because we lost all the hydraulics and it keeps coming up. Some failures. Keeps coming up, failures. So this is all we need to know. We will start hydraulic fluid pumps, the primary and the demand, and the engine, the left engine, right engine, and the electric backup. So we have all the hydraulic power. Now this is the electric. We can turn off the electric. You will see electric left and right, but we have the APU now on, so it's not a problem. Electrical reset. We have here the window heat. We have the passenger oxygen. I told you I control computer, thermometer, turbine. This is the lighting inside and outside. Windshield wipers left and right. We have the cargo and the cargo and the APU fire. We have the electronic engine control for the Farex and the engine, the auto start system on and off, controls the engine, auto start function, and we have 10 minutes to start the engines now. So we can dump some fuel, select how much fuel to remain. We have the left wing, right wing, center tank, the fuel tank. You see the center tank is empty because it displays pressure. We can use the crossfeed. We have some fuel imbalance and some failure. So this is the pumps for the fuel. Wing and engine and the ice. We need it in the on, not or the auto. And this is I will show you now the bleeder from the left and the right engine. You can see the APU we use for starting the left engine first. So we turn off the bleeder. We do wing and engine on the ice, air conditioning, cabin pressurization, and hydraulic fluid. You will see how many systems we lose now. Also no bleeder for cabin pressurization, so you will see overflow, duct pressure 0, overflow, disconnect hydraulic pressure demands C1 and C2. I told you. Bleeder isolation, so we need to keep the bleeder also for starting the engine. If we use the bleeder from the APU, you can see here we have the cabin pressurization, auto or manual. We use the outflow valves, close or open when climb or descend to increase the pressure or decrease to pressurize or depressurize the cabin and select the landing altitude. So this is all in all the cockpit inside the Boeing 777. This is a nice review also now. One more thing we have to see the display here. So we have the flight management computer here and the display of the multifunction display. So we have the engine, the status. You can see the APU is running, the hydraulic fluid pressure and the oxygen, the checklist. We can set the normal menu before start, what we need to do very fast. We have a failure here. So we have also the communications. You can send messages, the navigation, synoptics. So we have the doors of the aircraft of the Boeing 777-300ER airplane is closed and the cabin is pressurized. You can see the landing gear, the pressure inside the tires and the temperature of the brakes, the electrical system. I show you the left engine, right engine, backup generators. You can see the flow of the current of the electric current and the battery charge and discharge, the voltage and the average. Hydraulic fluid, you can see 3000 psi pressure, the flow where it goes, which systems you utilize. Also the air pressurized C1 and C2, left engine, electric and right engine, and the shut-off valves. So we have the fuel, left wing, right wing, center tank, the crossfeed valves, low and high pressure fuel valves, the engine, total fuel, also left and right wing. The center tank, you can see yellow crosses and empty, and the APU also receives from the left wing from the direct current pump. You can see also the left wing, right wing is the air, the pressurizer from left and from the 5th and 9th stage, also from the APU. Cabin pressurization, wing and engine got the ice, air conditioning, and hydraulic fluid. Also if we increase the thrust from the engine, you will see the duct pressure increase rapidly here from the outflow valve. so we close it. Also we have the hydraulic here again. You can see where it goes. We have the flight controls. If I extend the speed brake, you will see I can move that around this and this. So we have the control of the flight controls over here displayed. So we go back into the mode, the engine, virtual cockpit. So we make an engine start demonstration now outside on the engine. This time maybe we have more time to display everything better. So we'll start the shut-off valve, fuel shut-off valve. We have the AP on. You will see the engine shut on, the N1, all the flow, so we have no fuel flow, but the N2 also decreases. You will see the spinning here from the turbofan. Front stage is decreasing, it will go down to 0. So I will show you how to start the turbofan, the engines of the Boeing aircraft. You can see now we have almost 0. So we go in the overhead panel, start both these controllers to the on position. So you will see the N1, the pressure increases. You still have the engine shut on, the duct pressure. The N2 above 20%, we can start the fuel flow, which is 0 right now. So this is how we have the pressurization from the APU, and we let the fuel on, both left and right wing. So you will see the fuel flow increases and the engine starts, both of them. So we can go now into the takeoff after one last step, very fast. Last step before flying, going into pre-touch. So we have the menu. You can see here the FMC, the model, the Boeing 777. This airport we need the GPS, inertial reference, Lszh reference position, set inertial position over here. Initial reference, the zero fuel weight and the gross weight of the aircraft, the reserves, how much fuel reserves we need, cruising altitude 35,300, the cost index 100%, the minimum fuel temperature, also departure and arrival airport, Lszh, runway 14, continuous route. So we have the departure, set the departure, Zui to Alpha, flight management computer, the route, and the arrival, Lszh 14, Trans-Negria, Trans-Amity. So we have the leg, activate and execute. So we have the flaps, 15 degrees, center of gravity 36%, and 133 V1, 140 V-loading, and 554 V-takeoff for this takeoff weight, and also the runway conditions and length. And we have this on the parking brakes and taxi to the runway now from our position. So we increase the thrust and use the tiller here for steering the aircraft into the ground. So the runway is clear, we can use it for takeoff because all the aircraft use the other aircraft runway right now. So we use parking brakes again for 1 second. You can see here all the indications are correct. Set the range. Here you will see the flight plan and the scan from the radar over here. So we have the scan of the radar, also the LNAV here. You can see the trim, the stabilizer trim is correct, the flaps is correct. So we increase the thrust over here. You will see the indication. So here we are, ready for takeoff. I will show you this nicer view for takeoff and disarm the parking brakes and go. Also use some steering here alongside the rudder pedals. So we have 100 knots, 133, V1 we rotate, start the rotation slightly, not pitching up above 10 degrees, V2 we take off. Be careful not to strike the tail in the takeoff thrust. So we have positive rate of climb with up to 9 gear. So we keep climbing, pitch down a little bit, using maximum thrust. So you can see here we are 1,600 feet above the ground, but 3,400 feet above the sea level. Also the airspeed, we are 2,500 feet above the ground, but 4,500 feet above the sea. Climbing 5,750 meters per second, feet per second. Excuse me, this is the airspeed. The flaps position, the limits of the flaps, and the pitch ladder, the degrees. You can see you can start the turn now, and we have, like, I believe, I'm gonna be having like it's gonna be having like 18 more minutes maybe for this flight. Video to end. So we keep climbing here. You can see our position. So I'll show you the outside view of the airplane as it climbs. So we reach the Switzerland. We have this beautiful view. We fly with about 500 kilometers an hour, or about 250 meters per second. So maybe I'll show you also the turns here. As we climb, this nicer view of the airplane, the wings of the Boeing 777, and we have a nicer so we keep climbing. You can see the rate of climb, we are 13,000 feet. You can see the target airspeed here. We still have the same 13,000 feet. And we have a few more minutes left to go. We have like 15 more minutes, which is like a good timing for the flight. You can see the thrust here, commanded by the Flught and the other thrust system, and it transfers a couple of waypoints here. So I'm gonna use this. Pitch down a little bit, avoid the stall. The warning here, have the yellow and the red. So you can see also how fast we climb with a small rate of climb right now. Because we are close to the stall speed, we need to avoid this. Limit climb at this altitude 1,500 feet per minute, and we have the next waypoint right now. We cross this with this waypoint here, as you can see. And we go to the next one. You see the distance. So we have the German in front of us, the Bayern Munich. As you can see, keep climbing. We have the lakes, the same Galen, the lake here. So 18,000. We have a few more minutes. We have 13 more minutes for this flight. High up. So we have the Germany this side, the Bayern Munich and the Bavaria. So the Bayern Munich is like 80 nautical miles from here in front of us. We could find this way. This way we have the Swiss Alps, 30,000 feet. $31,000 feet. We have 12 more minutes for this flight, so it's a good timing right now for me. Let me increase the airspeed selected here. And also retract some flaps. We'll increase the airspeed limit. Will give us a better limit for the airspeed. So you can see I'm flying manually right now. We're 31,000. 32,000. So we have to level a little bit. You can see the speed trend. We have Mach 0.5 right now, about 650 kilometers an hour airspeed. So we have the handrails now. It controls this beautiful display from the airplane. So this is our spacecraft for tonight, the Boeing 777-300ER, flying with about 900 kilometers per hour or 300 meters per second. We're going to be overflying the lake here, and we have the German in this side. So I'm going back inside. And we have like 8 more minutes left for this flight. So we are at 34,000 feet. We keep climbing. So we have the handrails now, as you can see. This beautiful view of the Boeing 777-300ER. And we have like 8 maybe more minutes for this flying. So we execute and fly direct to. And we have like 7 more minutes left for this flight. We keep flying with 900 kilometers an hour, 300 meters per second. And we have the autopilot now connected. Obviously, maybe select lower altitude now. For descent, so you can see we are here in the target, and select the flight level change and repeat brake descent, and also increase the airspeed a little bit. So we start commence the descent. You can see so this is our spacecraft for tonight, the Boeing 777-300ER. We have the star sign, the galaxies here. We fly with 900 kilometers an hour, 300 meters per second. We cross here, we leave behind Germany, we cross Switzerland, and we go in Flught. So this is a beautiful galactic view. The handrails, leave it behind. Keep going down into the runway. So we have like 6 more minutes left for this flight. 38. Six more minutes is a good timing for us. So you can select lower airspeed here. Also different gates are maybe the autopilot only. So we have the scan from the radar again. Also select the landing airspeed. the approach landing speed, the approach reference. Maybe disconnect the autopilot in a couple of minutes and fly diversion. Maybe. So we're gonna use this the landing gear down as some flaps. So we have the runway this way, here with us. So we disconnect the autopilot like this, fly manually. Keep coming down, flaps full, and the airspeed down. And we have the vol localizer also. So we have the idle thrust, the speed brakes are extended. You need to keep coming down like this. So we have the runway. We need to start turning into the runway faster. So we have the river in front of us, the runway. So we use simulation rate normal, and we have like we have like 3 more minutes, I believe, for this flight. So here we are going down to the runway. Also show you a nice view for maybe the touchdown. I don't know. So here we are with the Lszh localizer flying manually, and also use some thrust, manual thrust and inputs. I cannot show you everything here right now, but it's good to know. Flying VFR. Also have the Lszh localizer inside. The glide slope, as you can see, add some more thrust if we need, and level off to the runway feather line, as you can see. So here we are, Lszh localizer, aligned with the rudder pedals also, and so we are inside the Lszh localizer, the glide slope, as you can see in the information, the runway, the radio altitude above the ground level. So we decrease the thrust and go for landing. So we are here. Aligning a little bit. We are ready for the flare. Leveling off. Flare. 10. Here we are. Beautiful touchdown and landing. Parking brakes. And reverse thrust. Here we have full reverse thrust. Slowing down the runway. Just touched down with 174 knots. 270 kilometers an hour. Horizontal component of the airspeed, very smooth landing, Lszh localizer and VFR. So you can see here we have, you can see the nose wheel, the tires, there is no breakage, not like some other people are doing with their aircraft. The aircraft is standing well. Also the landing gear behind. You can see all the wheels and the switch from the aircraft is completely safe. So we made a beautiful landing, very smooth. Here in the runway 14 and almost center line. Here to the National Airport. So you can see everything inside the aircraft is normal. You can descend with right reverse. After the slowdown, we taxi. So that was Thomas Hatsios, the British American pilot of the United States Air Force, flying the Boeing 777 airplane in tonight's flight. The beautiful airplane. So thank you very much. I'll see you next time. Bye bye. Muchas gracias. We have the